Alright, so I've always had a problem with this idea of binary operators and non-commutativity. Neither of these make sense to me. Okay, so if you look at every Lie group that I've looked at so far, uh, also some Galois groups, and like I think this is just how it works. When you have a non-commutative operator, what's actually happening is in the middle of doing the alleged operation, the alleged binary operation, you're shifting around your reference frame. And this results in non-commutativity. Okay? And when you don't do this, when you have a static reference frame, you get commutativity. Also, it becomes a proper batch function. You can just throw in an unordered list of objects, perform the operation over all of them, and it doesn't matter what the order is, which spell out you use. It comes out the same regardless. It ends up being a batch function. So, like, the idea of addition over the integers being a binary operator doesn't make sense anymore. And the idea coming from, like, matrix multiplication that, oh, this is a binary operator and it's non-commutative. No. No. Okay, so look. So, say we are, we tell somebody to walk forward, then turn left. Okay. This, we can break this down into, let's do it that way. Let's do it that way. It doesn't fucking matter. Let's break this down into walk forward. The operator is then, and then our second our argument is turn left. Okay. Now, is this the same as turn left, then walk forward? Okay, so here we go. Now this is turn left, then walk forward. No, these don't do the same thing. This then operator is non-commutative. And what ends up happening is every non-commutative operator is then. This isn't even a verb. Like in the English, this is not a verb. This just indicates a sequence of alterations to our reference frame. That's what it's doing, and that's what every non-commutative operator that I've been able to find in group theory is. Every single one that I've looked at, that's what it is. There might be something else that's going on at some level that I haven't seen, and I'm totally fine with that possibility because I've definitely not looked into everything at all by any means. But everything I've seen where we get non-commutativity, the alleged binary operator is actually just a sequencer. It's just taking two actual operations, and ordering them in sequence. It is literally just the English word then. Do this first, then do this. And a lot of times you do the one on the right first, and then the one on the left. Because I don't know, we're reading in Hebrew or something? I'm not entirely sure why the order is that way, but it is. Usually, almost always. It's weird. The exceptions are random. They do exist. Like I think when you're working in S1, you can read it left to right. Anyway. Yeah, so like the compose operator in S1, I think you read that one left to right. Or it doesn't matter. No, it definitely matters because it's non-commutative. Anyway, But, okay, so watch what happens if I change it this way. Walk north, then turn west. Okay, so now we get, this is commutative with turn west, then walk north. Okay, so if we are explicitly following these directions and doing nothing other than what is said, the results of these two things are the same. You end up north of your current location, facing west, regardless of which order we do it in. And all we did was change our reference frame. The reference frame here, where the hell is my cursor? Alright, the reference frame here equals the person who's walking, the person who's acting. The reference frame is their body. Here, the reference frame is everything. The world. Just by changing the reference frame, we can take the same exact instruction, which is non-commutative in one reference frame, change our reference frame to something static, and now it becomes commutative. Right? We change the reference frame to something that's not being altered by the operations we're doing, and suddenly it's commutative. This is why I have a problem with this. So, like, I am under no delusion that this is, like, something that I have uniquely discovered or anything. But this is not something which is discussed. This is not something which you can easily find anyone talking about. And it's fundamental. Right? And if there are groups where the non-commutative operators are genuinely, like, something different than this, which I haven't found, as far as I know, all non-commutative operators over Lie groups work this way. As far as I can tell. There are absolutely large gaps in my knowledge at this point, but I have looked at quite a few of them, and they all look like this. They all act this way. Right? So if you have a static reference frame, you can turn a non-commutative, let's see, non-commutative binary operator becomes commutative batch operator. I can't spell for shit. Okay. If we choose a static reference frame. That's it. That's all you got to do. As far as I can tell. And I'm actually really excited to find exceptions to this, because that means that there's something else, something completely different from this at play, which I have not seen at all. Like, I want to be wrong about this, but I know for at least a lot of Lie groups, this is actually what's happening, for sure. So, like, S3, S1, right? So, like, working with the circle and working with the unit sphere, where you get the complex numbers and the quaternions, you can make the operations, all of them, you can make them commutative if you just change your reference frame to something that is static and not altered by the operations that you're executing. And the non-commutative operator isn't actually even an operator, it's just a sequencer. It just sequences the actual operations that you're doing. Which is usually why it has to be defined in some strange way. Like, you have to define like the over S1, right? You got the little plus sign with the circle around it, or the minus sign with the circle around it. You have to define those operations, and it's defined as a sequence. Because and that's why they're not necessarily commutative. because it's a sequence. Anyway, yeah, so at this point in time, my evidence-based belief is that non-commutative binary operations don't actually exist. They are not a fundamental thing. What they are is an artificial construct derived from using the wrong reference frame over batch operators, commutative batch operators, which accept unordered lists of any number of arguments. So this is why addition and subtraction are actually commutative. When you view it as summation, what we're doing is we're taking unordered lists of integers, and our reference frame is the real axis, the real number line, which is static. It doesn't change based on what we're doing with the vectors, the integer vectors. That's commutative because it's just this batch operation. We can use any spell out. It doesn't matter which order we put these in. You get the same thing regardless, right? So you get, 5 plus 7 minus 18 plus 12 plus 3 is the same as 3 minus 18 plus 5 plus, where the fuck am I? There's a 12 in there and a 7. Right? Those are the same thing because of this. Right? Because the operation is summation. It is not a binary operator, so it's not indicated with the plus or the minus sign. It's not indicated with those. What it is it's this batch operator which accepts an unordered list of integers. Right? And the integers are signed. So we can rewrite this without changing anything about the meaning this way. This set, this list, this unordered list, these two unordered lists are the same thing as each other, assuming I got all of the elements right. 5 and 5. Yeah. So those are the same thing. Because what our batch operator, our commutative batch operator, is summation, not addition or subtraction. Addition is this apparently commutative binary operation. But the reason that it works that way is because it's been misidentified what addition even is. Subtraction is a non-commutative binary operator because it's just fundamentally misunderstood what the fuck we're doing. If you put them together correctly and you choose a static reference frame, you get a commutative batch operation, and that commutative batch operation is summation. And you can do the same exact thing with, I think, all of the Lie groups. All of the non-commutative operations over all of the Lie groups can be reinterpreted in this sort of way. Which makes shit way the fuck easier. As is generally the case, when you look at it correctly, it's a little bit simpler. Like that little animation that I posted last night about this is pretty much everything that's happening in S1, and it's literally just a circle with the real and the imaginary axis indicated with lines, with arrows pointing to the positive real and the positive imaginary, and it just rotates against the cover, and the vectors on the cover slide correspondingly with it. That's really everything. But in order to explain it with the Lie algebra that handles this, you have to learn a whole bunch of other shit, because fundamentally what we're doing is we're thinking about it in weird ways. And the notation is handling it has all of these weird esoteric aspects to it because we're fundamentally not thinking about it the right way. At least that's how I see things currently.